Common sense. It spreads through the world until it becomes impossible to challenge. For a TDR measurement, using an oscilloscope is the best choice. Isn't this also a type of common sense that people have given up on challenging? It's time for a new option. It's time for ENA option TDR. Setup should be a breeze for those used to working with a TDR oscilloscope. Let's try deskewing for a differential device. First, you push some buttons, then enter in some values, adjust some dials, and click a few more buttons. You might feel flustered by the number of operations the first time, but once you learn what you were doing, you get used to it. If you can get used to it. This time it took us 15 minutes. Pretty good. Of course, with experience, it can be done much faster. Compare this to ENA option TDR. When you first come in contact with the instrument, you may think that you are missing something. Why, the procedure for deskew can be done with one click. All troublesome settings are taken care of automatically by ENA option TDR. In the time it's taken me to explain the procedure, our deskew is already done. Using an ENA option TDR, a procedure which took 15 minutes on an oscilloscope took a mere 10 seconds. That's all the time it takes for even a complete beginner to acquire the same results you'd get with a conventional instrument. What's more, with ENA option TDR, the user interface is always smart. Time domain and frequency domain is displayed on one screen. And you can zoom in on either one at the touch of a button. You can change parameters, such as rise time for time domain or mode conversion for frequency domain at any time. Displaying an eye diagram couldn't be easier. Simple and intuitive operations. With the ENA option TDR, everything's quick and easy, and that's something everyone can appreciate. There is no engineer who likes noise. TDR oscilloscopes, you can get cleaner values by averaging to reduce random noise. Now imagine, what if noise was low to begin with and there was no need to use averaging? Perhaps ignorance is bliss. If you didn't know this was possible, it wouldn't be a problem. Conversely, let's take a look at ENA option TDR. Because ENA option TDR is a low-noise instrument, it is possible to get clean values without averaging. With this, you can even view value changes in real time. Of course, if you are so bold as to believe that you don't need to measure small discontinuities in high-speed applications, perhaps this will mean nothing to you. People often say that slow and steady wins the race, but when it comes to measurements, the best data is accurate and real-time data. Let's talk about that terrible villain, static electricity. The tremendous damage that static electricity can cause to an instrument means it's important to take every possible precaution against it. Oh no, and now of all times? Next time, don't forget to wear a wrist strap. Under usual circumstances, I would tell you to call customer support and fast. But nothing is quite usual about ENA option TDR because it has an ESD protection circuit built into the instrument. ENA option TDR has been designed and tested to withstand 3,000 volts of ESD. Furthermore, the Agilent proprietary protection circuit will not sacrifice instrument performance. With this, you need not worry about unforeseen static electricity. From now on, you do your measurements with peace of mind. While some facts of life can't be avoided, there's no place for ESD issues in the workplace. Simple and intuitive operation, accurate and real-time troubleshooting, high robustness against ESD. These three breakthroughs are sure to make today's TDR common sense a thing of the past. Break TDR common sense. Break it with ENA option TDR.